Welcome to Math 1324. This is section 4.1. In all of chapter 4, we're looking at solutions to systems of linear equations. What does that mean? Well, a system means we have more than one equation, and we're looking to see, do these equations have a common solution or not? So here in question 1, we have one of these systems. I have two equations. When I have two equations, geometrically what's going on is I've got two lines. So the question becomes, well, what can happen if I had two lines? Well, my two lines could be as in this case, and there could be one common point of intersection. My two lines could be parallel, which would mean they would never touch, they would never intersect, there'd be no common point. And it could actually be this case, which seems silly, but that I have exactly the same line, and the two lines are actually sitting on top of each other, and therefore they intersect at every point. So let's look again at our system. So here's our system. We have y is 1/3 x minus 4. Graphically, I see that the slope is 1/3, so the line is going up, and it's crossing at -4. So here is that line in blue, roughly crossing at 0 minus 4 and going up. The other one, x equals 12, notice there's no y variable in there, so this is just a vertical line. And it's a vertical line crossing here on the x-axis at 21. So graphically, I can see that the two lines should intersect somewhere. And we're going to see that that point is at 21,3. So to solve it, I'm just going to use substitution. I simply take my x and substitute it in to the first equation. 1/3 times 21 is 7. 7 minus 4 is 3. And so the common point where these two lines intersect is at 21,3. All right, let's see. Here in question 2, we have two equations. We would like to figure out, well, where do these two intersect, if at all? Now, I'm going to solve it first, and then we're going to look at the graph that matches. And I'm going to use a technique called addition to solve it. My hope is I can multiply one or both equations by something so that when I add them up, a variable cancels. My focus here at first is to look at the x variable. See, I've got a -3 and a 6. If I multiplied this whole equation by 2, I'd have a -6x and a 6x, which when they added would cancel and be 0. So I'm going to multiply all the way across everything by 2. So -6, -8, and 4. And so you see now when I add these up, the x's go away. -8 plus 5 is -3. 4 add a -5 is a -1. And so now I'm going to divide both sides by -3. -1 over -3. The negatives can cancel, and I get that y is 1/3. Now, I could substitute this back in and figure out what is x, or I could just go back and do the problem again, trying to eliminate a different variable. Okay, so here I'd like to get rid of the y's. Well, let's see. I got a minus 4 and a 5. I'm thinking if I multiply this by 5, I'd have a negative 20. And I multiply this by 4, I'd have a positive 20. And they'd add up and cancel. So I'm going to multiply all the way through the first one by 5, all the way through the second one by 4. All right, all the y parts do cancel. Let's see. 24 minus 15 is a 9. Minus 20 plus 10 is a minus 10. And so divide both sides by 9. And so I now know that the two lines do intersect, and they intersect in this particular part. A negative x and a positive y. So now let's see which graph might look like that. Well, let's see. Well, it can't be A. A only has one line. That can't be positive. And if you look here at B, the point of intersection is sitting over a positive x. Similarly here in D, this point of intersection, the x part is positive. So that rules out A, B, and D, leaving us D. And yes, that does look like about a negative 1. Why do I say negative 1? Well, because 9 over 9 would be 1. This is a little more than 9, a little more than 1, so therefore it's right about there. So yes, it is C. All right, question 3. We have a system again, and they want us to solve it by substitution. So when you make substitution, you try to pick an equation that's easy to get one variable by itself. And I see this x sitting all by itself. That looks easy, so I'm just going to move the y to the right. So move the y to the right, it becomes positive, and now there's my substitution. I'm going to substitute it into the other equation, and I'm substituting it for x. So there it is. It's in parentheses because the 2 is times all of x. So 2y minus 10 plus 6y is a minus 18. All right, let's see. 2 and 6 is 8. Bring the 10 to the right. 10 minus 18 is minus 8. And so now divide both sides by 8, and I get y is minus 1. What about x, you say? Well, come back up to my substitution. Here it is. Put in minus 1 minus 1 minus 5. Minus 1 minus 5 is minus 6. So the one common point of intersection is at that location. All right, in question 4, they say solve this by adding. Well, I want to add them up and get rid of either x or y. Well, looking at this, look, I've got a plus 2 and a minus 2. I can just add these up like they are. So add them up. These cancel. 2 and 2 is 4. 4 and 4 is 8. Divide both sides by 4, and I get x is 2. That's easy enough. So now, what do I do with the 2? Well, I'm going to take it and plug it into either one of these and figure out what is y. So I'm plugging it into the very first one. See, right there. 2 times 2 is 4, plus 2y is 4. Move the 4 to the right, so 4 minus 4 is 0. And now divide both sides by 2. And I get 0 over 2 is 0. And so y is 0. So there is one common point of intersection, and that is at 2, 0. Now, just to reiterate something we just did, 0 over 2 is 0. But if it were reversed, 2 over 0, this would be undefined. So if 0's on the top and the bottom is not 0, then it's 0. If 0 is in the bottom, it's undefined. And if we had the unfortunate case of 0 over 0, this is called indeterminate, which is a fancy word for saying we need to do more work to figure out what's going on. But these are just 3 cases of what could happen with 0 in case they come up during the course. All right, question 5. I want to solve this by adding. Well, right now, nothing is going to cancel if I add them straight up. So let's see. I'm thinking I'm going to get rid of the ends. So I'm going to multiply this by a minus 5. Minus 5 times minus 1 would make a plus 5. These would cancel. All right, so I multiply through by minus 5. And now I'm going to add these up. Remember, minus 5 all the way across. So minus 25 and 1, so a minus 24. I get a minus 144. Divide by minus 24, and I figure out that the m variable is 6. I'm going to plug that in now into the very first equation here. So let's do that. So here it is, right here. And so 5 times 5 times 6 is 30. Minus n is 26. And so now I'm going to move the 30 over. So that would give me a minus n is a minus 4. And I get n is 4. Or if you like, I could move the n to the right, making it positive, and then I'd have 30 minus 26, giving me n is 4. So there is one common point of intersection, and that would be at 6, 4.